Number 1, rational exponents. It's concept 3, right? 27a to the negative 3, all to the negative 2/3 in simplest form. The way I like to handle these is I like to break them apart. So let's break this apart, make some space here. Break this apart. We've got 27 to the negative 2/3 times a to the negative 3 to the negative 2/3. I'm going to forget about this negative sign for a second. I'll ask myself, what's the cube root of 27? That's 3. Square that, I get 9. The negative then is going to flip that over. That's going to give me 1/9. A negative times a negative, I get to multiply these powers together. The only time I get to multiply powers together is when I have a power to a power. So a negative times a negative is a positive. 3 times 2/3 is just 2. So this is a squared. Let's get a pen instead of a highlighter. A squared. So this is all a squared over 9. And we're done. Any questions at all right here? Let's do number 2. It says write the exponential expression in radical form. The 6 we're not going to touch. The 6 isn't being touched by the power. The 6/5 is only on the x, so it doesn't affect the 6, so leave the 6 alone. The 6/5 says that this x is in a 5th root. So we'll put the x in a 5th root, and the 6 on the top says that it's being raised to a 6th power. So we'll put x to the 6th inside of a 5th root, leave the outside 6 alone, and we're good. Any questions or comments or discussion here? Step 10, we're going to write the equation in log form. So I've got this exponential equation. They just want it written in log form. So I know this is log of something equals something. Actually, I think I'm going to need more room for this one. The base always stays the base. In the expression that's already written, the base is 4, so the base stays 4. When you guys write these 4s, make sure you write them as subscripts, not on the same line, not as powers, not superscripts either. We also know that logs always equal powers, or always equal exponents. So the power here is 7, so it's going to put a 7 on the other side of the log. Logs always equal powers. The only other number left is the 16,384. It's got to go right here. So log base 4 of 16,384 is 7. We're done. Questions or discussion here? Number 4 says evaluate this. They want to know what this equals. Log base 7 of 49 equals something. The way to figure out what it equals is just ask yourself 7 to the what? 7 to the what is 49? What do we have to raise 7 to get 49? 2. So the answer there is 2. We're done. Number 5, concept 11, solve log of 4x plus 3 equals 1. If I don't see a base written here, what's the base have to be? 10. So my first step would be to say that 4x plus 3 is equal to 10 to the 1, the base to the power. So 4x plus 3 is the same as 10. If I subtract 3 from both sides, 4x is the same as 7. And if I divide both sides by 4, x is equal to 7/4. I can just stop right there. I have solved that equation for x. Questions or discussion here? Number 6 is similar. It's just a little more complex because we have 2 logs on the left. I've got log of 5x plus log of 12. That equals 1. I can combine these 2 logs using the law of logs. This is the same as log of 60x. 5x times 12 is 60x. That equals 1. I don't see a base here, so it has to be 10 again. So I could now say 60x equals 10 to the 1. And divide both sides by 60. I'm going to get 10/60ths, which is the same as 1/6. So we're done right there. It says round to the nearest hundredth if necessary. So let's go ahead and be necessary and round to the nearest hundredth, which would be 0.17. And follow the directions all the way through there. Questions or discussion there? Number 7, we got some factoring to do. The numerator will factor. I'm going to change the variable to x just so I can write it quicker. I need 2 numbers whose product is 21, whose sum is -10. That would be -3 and -7. The denominator, same thing. I need 2 numbers whose product is 35 and whose sum is -12. That would be -5 and -7. These 2 factors are the same, so I can just knock them out, x squared minus 7 and x squared minus 7. So this whole thing simplifies to x squared minus 3 over x squared minus 5. I need to state restrictions. I'll go back to my original variable. I'll just keep saying x. X can never be plus or minus root 5 or plus or minus root 7, because that would give me a 0 in the denominator on these other two fractions. These other two factors, I should say. That's my final answer right there. Any questions or discussion? For 8, we've got to deal with a little division here. So we know that's invert and multiply, so let's just go get after that. Q minus 1 over Q plus 4. Let's do the inversion here and factor at the same time. So the Q minus 5 will go to the bottom. And then this other trinomial will go to the top. Let's see if we can factor it. I know I'm going to have a Q and a Q. And I know I got to find two numbers whose product is negative 24 and whose difference is 2. Negative 6 and 4 should do the bill there. They multiply to negative 24 and add up to negative 2. The Q plus 4s are the same, so they can be reduced out. So that's going to leave me a Q minus 1 and a Q minus 6 all over a Q minus 5. And I need to restrict Q. Q can never be negative 4, would zero out this factor, or positive 5. And we're done. Because it would zero out this term right here. You can't divide by 0. Number 9, we need to add or subtract. We're adding. Let's find some factors. Top one, I need a y and a y. I need two numbers whose product is negative 10 and who are 3 apart. That should be negative 5 and positive 2. Well, they have a difference of 3 when you add them together. So negative 3. The bottom, same thing. I've got y and a y. Need to multiply to make 35 and add to make negative 12. That should be negative 5 and negative 7. They multiply to make a positive 35. They add to make a negative 12. The y minus 5 and the y minus 5 go out. So right away, we're down to something that's y plus 2 over y minus 7 plus a 1 over y minus 7. I've already got a common denominator. So this problem is kind of interesting where the denominator just falls out nicely for me. Y minus 7. The top I have y plus 2 plus 1. That's just y plus 3. We're as simple as this one can get. It said simplify as possible. Did not ask for restrictions, so we won't give any. And we're done. Discussion or questions here? In number 10, they're claiming it's complex. They want us to simplify it. I'm going to multiply everything by the LCD of all these little denominators right here. I know I need a z. I also have to get work in a 2, a 3, and a 4. I think 12z will work for that. So I'm going to multiply every fraction by 12z over 1. And see what happens. The first thing that's going to happen is the z's all just go out. They just all reduce out. You might not do yours in the same order I'm doing mine, but that's kind of a nice thing. And then we just start reducing. I'm going to start keeping track now. Got a minus up here and a plus down here. 12 divided by 4. Well, the 12 and the 4 will reduce this to a 1 and this to a 3, right? 3 times 3 is 9. Over here, 3 goes into itself once and it goes into 12 4 times. 2 times 4 is 8. So I'm done with the numerator. Go to the denominator. 3 goes into itself once. It goes into 12 4 times. 4 times 1 is 4. And finally go to that last little fraction. 2 goes into itself once and into 12 6 times. 3 times 6 is 18. So I'm getting 9 minus 8 is 1 over 4 plus 18 is 22. We're done. Questions or discussion here? This one I looked at and said, thank you very much. Why? Because they gave me common denominators. They just said, here's a common denominator. And I said, thank you very much. This is 4 over 5p equals negative 6. Multiply both sides by 5p, you get 4 equals negative 30p. Divide by negative 30. 4 over negative 30 is p. Therefore, P is what? Negative 2/15, and you're done. If you don't have a common denominator, then you got to force one so you can add the fractions. So you either got to find one or you got to multiply both sides by something to clear the fractions. We got some students that are helping the homeless during their spring break. Good for them. They're not going to Cancun. They're helping their homeless. Maybe they're helping the homeless in Cancun. Who knows? They're putting finishing touches on the house they built working alone. Jillian can paint a certain room in 5 hours. Mike can paint the same room in 10 hours. Write an equation that we use to find. So I want an equation. Use to find how long it will take them working together to paint the room, and then how many hours will it take them to paint the room together. If necessary, we're supposed to round this off to the nearest hundredth. All right, so how many hours in the equation? This is a classic work problem. In work problems, you have one person's work plus another person's work equals the whole job. It's one whole job. Jillian will get X fifths of the work done in X hours. If she works 5 hours, would you agree she'll get the whole job done? 5 out of 5 is 1. Mike will get X tenths of the job done in X hours. If he works 10 hours, will he get the whole job done? 10 over 10 is 1. Yeah. How many hours do they need to working together? We just have to solve this equation to figure that out. So here's someone's question for the last problem is, what if these bottoms aren't the same already? Force them to be the same. One way we could force them to be the same is to just find a common denominator and work with fractions. Another way is to clear fractions by multiplying by that common denominator, which is 10, right? If I take 10 times x over 5, won't I get 2x? If I take 10 times x over 10, won't I just get 1x? And then 10 times 1 is 10. Fractions are gone. We're all happy. 3x equals 10. X equals 10 thirds. If we round it to the nearest hundredth, that is what? 3.33 hours. It's too bad they didn't say round to the nearest minute. Because a third of an hour, I think we all know, is... Questions?